All right, welcome back to our 6-5 notes on graphing quadratics. All right, so if you take a look at this next example, we can take a look at graphs in the vertex form, where y equals a times x minus h squared plus k. So it's a different way to write our quadratic formula. This is going to be just a different way to express that ax squared plus bx plus c. All right, so our vertex is hanging out at hk. So remember that vertex is either our lowest point or our highest point. All right, so notice here it's x minus h, so we would have to change the sign on h to find our regular old h, and then k is being added onto the end. All right, so if I take a look here at this first example, I wanted to get it to match that formula. So I notice in the middle here I have a minus sign, and here I have a plus. So I know positive comes from minus and negative. So that would make my h coordinate -3, because I'm subtracting -3 from x. I'm adding on a +4, so my k is hanging out at -3, +4. So I can start by graphing that point hanging out right here. All right. I also might take a look and notice that my a, the value in front of my my squared term, I'm going to notice that is negative. So I can deal with this in terms of an upside down u. I know my u is going to be facing downward. All right, so now I'm going to pick 2 points on either side of my axis of symmetry and see what happens. So let's say I want to pick, I'm going to pick -2. All right, so -1/2 times 1 squared plus 4. All right, so when I do that, I have -1/2 plus 4. That gives me +3.5. So I plugged in -2. I'm going up 1, 2, 3.5, hanging out here. I'm going to use the idea of my axis of symmetry going through my vertex, and I'm going to get my mirror image point hanging out over here. All right, to check out something else, I can check out 1. So if I plug in 1, let's do -1, why not? Any points will work. All right, so I have -1/2 times 2 squared plus 4, or -1/2 times 4 plus 4, or -2 plus 4, which gives me 2. So I plugged in -1 and out popped 2. Using my axis of symmetry, I can get my mirror point over here, and I can connect these as a smooth curve to get my upside down u that I was expecting. All right, one more way that we might take a look at graphing a quadratic is in our intercept form, where everything is just going to be, it's going to be factored completely, and it's going to be a product of monomials and binomials. All right. And in this case, the p and the q are going to be our x-intercepts. These are also known as the roots of our equation, so where we're passing through that x-axis. All right, so taking a look here, to find my roots, all right, I got my mini algebra problems. Okay, so if x minus 6 equals 0, I can add 6 to both sides, and x equals 6. All right. In this next problem, if x minus 4 equals 0, I add 4 to both sides, and x is 4. So my two roots are a +6 and a +4. I'm going to plot those right here. All right, so I know that somehow my U shape has to crash through both of those points. And I notice because my a value is positive, I know that somewhere along the way I'm going to end up with a U shape facing upwards. All right, so my x-intercepts are x equals 6 and x equals 4. All right, and I know that somewhere halfway through those 2 points I have my axis of symmetry happening here. So I can kind of eyeball that in here, and I notice it's happening at this spot of x equals 5. If I didn't see that, if it wasn't so obvious, I could add up my x-intercepts and divide by 2. I'm finding the average of those x-intercepts. Okay, and so I end up with x equals 5. All right, so I know it's going to be a U shape. It's going to be centered around x equals 5. So now what I need to do is find the y coordinate of my vertex. So we're going to take 1/2 of 5 minus 6 times 6 minus 4. All right, so 1/2. Oh, and I didn't put that in there right. All right, let's fix that up. 1/2 of 5 minus 6, and then 5 minus 4. There we go. Plugging in my x value of 5 into both of those spots. All right, so I have 1/2 times -1 times a +1, which turns out to be -1/2. So I plugged in 5, and out popped -1/2. All right, so I plot that point of, I can write that clearly over here. I knew that my x-coordinate of my axis of symmetry was hanging out at +5, and that -1/2 came out as my y-coordinate.
Attention students, if you are not working with an activity or a teacher, it is time to leave the building. Thank you.
All right, so now I can check out some things hanging out near that point. And actually, I only have to do one more, that would be fine. All right, so I already have things hanging out for 4 and 6. Let's just try 3. All right, if x equals 3, I can plug in 3 minus 6 times 3 minus 4. So I have 1/2 times -3 times -1. So I have 1/2 times a +3, and I get 3/2 or 1.5, whatever floats your boat. So that point is hanging out at 3, 1.5. I can use my axis of symmetry to get the mirror point on the other side, hanging out at 7, 1.5. And I end up with my U shape hanging out. All right, that will do it for our notes. All right, see you in class. Bye.